Hey everyone! We've been pretty quiet on here recently, and we wanted to let you in on a few things. We're making some big changes this summer, personally and professionally, and we'll soon be in a place to devote more time and have more options for projects of ours and observations on this channel. Basically, we might be kind of going off the grid. We'll discuss that more in the near future, but in the meantime, we want to again summarize some of the various observations we've made over the years that demonstrate the effect of light refraction across horizontal surfaces. We started these observations on some acreage we own in the Colorado mountains, and we also went to local tennis courts. We chose a spot on our land where water collects during a heavy rain and forms a very small pond. We did this in order to find the most level point to conduct these observations. We placed the camera on one end of where the small pond forms and arranged the objects on the opposite end. The surface itself was not perfectly smooth and there was some undulation, but the objects could be seen in full when the atmosphere would allow it, like it did on this evening. As you can see here, the full light from the distant objects was able to reach the viewer. We were at a viewing height of around 1 1/4 of an inch, and the objects were no more than 150 feet away. However, most days the light from the objects was not able to reach the viewer in full. As you can see here, the very bottom of the objects are hidden from view. We had to raise the viewing height of the camera in order to see the objects in full. These observations took place during the late fall, early winter. The temperature during these tests were no more than 50 degrees Fahrenheit, with many observations taking place in much cooler weather of 30 degrees and less. So even in conditions without much heat or humidity, this upward refraction effect still occurs. Some days the sinking effect would be more drastic than others. Different days in various conditions brought slightly different results, but the light from the bottom of the objects was often unable to arrive to the viewer. At the same time we were doing these tests on our land, we were also conducting observations over tennis courts and found that the rate that these objects were disappearing bottom up was very similar to the rate of the alleged curvature drop of the Earth and the amount of obstruction the globe model predicts. These observations also took place in cool weather of no more than 50 degrees, with the majority occurring in much cooler temperatures. Here we raise our viewing height, and the light from the objects can be seen in full. Next, we decided to make these same observations across small bodies of water. We made sure that curvature could not be claimed as the cause of obstruction in these observations by conducting them at a distance of 600 feet and less. At 600 feet on a sphere of our given dimensions, there would only be about 1/10 of an inch of curvature drop, and the horizon would be over 2,200 feet away from our viewing height. The same bottom-up disappearance phenomena is witnessed consistently and also at a rate that matches the proposed curvature of the Earth. Viewing from 1 1/2 inches at a distance of 600 feet is equivalent to a viewer at 7 1/2 feet viewing at a distance of 6.8 miles. At 6.8 miles, the globe model predicts 8 feet of obstruction, which would be just over 1 1/2 inches to scale. And day after day we would witness 1 1/2 inches or more of apparent obstruction due to, again, upward light refraction. This light refraction that causes objects to disappear bottom up is witnessed in all kinds of conditions and also, at times, in the evening. or over ice. Again, these small bodies of water are horizontal, and the fact that the apparent obstruction witnessed matches so closely to what we see over large bodies of water is telling. We've also made at-home observations on our living room floor. By opening our patio door and letting the cold outdoor air mix with our indoor environment, this upward refraction sinking effect is again witnessed. We lift our viewing height, and the light from the distant objects arrives in full. We let the cold outdoor air inside a few different ways, both right at the surface and up near the ceiling, and also just by letting the cold air in evenly. The results varied just a bit by doing so, but each time the bottom of the objects were hidden from view after the air was allowed in. And the full light from the objects would then arrive to the viewer when the door was shut and the air in the room evened back out. Check out how, in these observations, the more distant objects appear higher than the closer objects at the start of the observation. But as the outdoor air is allowed to mix with the indoor environment, the more distant objects appear to sink and no longer appears higher than the closer object. These observations demonstrate how upward refraction creates apparent obstruction across surfaces where no actual obstruction is present. And they also show apparent horizon drop, creating a false horizon which appears closer to the viewer. Could these atmospheric effects that are witnessed consistently across these various horizontal surfaces, both land and aquatic, be the same phenomena that is occurring when there appears to be curvature on a large scale? That's the question that interests us so much. Thanks for watching. We'll see you soon.